Let's take another question from electrical energy and power. Question number 2. Suppose there is a heater from 220 volt supply line. The heater draws a current of 6 ampere. To find the power of heater, and this is the question. Let us solve this. So from 220 volt line, the heater draws 6 ampere current. So power of the heater is V into I. So this voltage will appear across the heater, and that voltage into the current is giving the power 220 into 6. This is the answer. The power of the heater is watt, that is 1.32 kilowatt. This is the answer to this question. Now, how much energy it consumes in 2 hours? Energy consumed by the heater. The heater is drawing current, so it will eat the energy. Energy consumed is VIT, that is power into time. Power is 1.32 kilowatt and time is 2 hours. So it is 2.64 kilojoule. Okay, or kilowatt hour. And this has to be converted into, in terms of joule, it is again we have to convert it into, okay, let me just do this here. This is kilowatt hour. Now if you want to convert this into joule, then 2.64 kilowatt hour is 2.64 into 3.6 into 10 to 6 joule, because 1 kilowatt hour is 3.6 10 to 6 joule. So whatever comes out, that is the answer. So this is the answer to this question. Let us take another question. Question number 3 on power. Suppose there is a resistor here. 2 resistors I will consider. One is 2 ohm, another is 3 ohm, and one over here is suppose 4 ohm. And this is connected to a battery of 10 volt. Okay. So the question is, what is the power consumed? Power consumed in 3 ohm. Power consumed in 3 ohm. So this is the question. Okay. Now, so for any resistance, the power formula for any resistance, the power is either I square R or VI or V square by R. Any formula you can use. So I'll just use the first formula. R is 3, and I want to know the current that is flowing through this. If I get the current, then squaring that current multiplied by 3 is the answer to this question. Now, to find the current, we have to find how much current is actually coming from here. And suppose the current is divided into 2 parts. The current I coming here is divided into 2 parts. Suppose this is I1 and this is I2. So answer to this question will be power in 3 ohm is current I1 square into 3. That is 3 I1 square. So we have to find the I1 to get the answer. Now, how to get this current when more than 1 ohm, that is more than 1 resistor is involved in a circuit. Here it is 1, 2, 3. There are 3 resistors connected in the circuit. If it is more than 1, then we have to write the equivalent resistance of the whole bunch of resistors. So this cluster of resistor is to be replaced by a single resistance, and if this whole thing is replaced by a single resistance, say R, then you can write the current. Okay, so first find the equivalent resistance. If I can get the equivalent resistance of the whole system, then this circuit diagram will be reduced to equivalent to a single resistance R, suppose R equivalent, and the current should be same, and this is 10 volt. If the replacement of a single resistance in place of these 3 draws the same current I from the battery, that means this R equivalent is a equal or equivalent replacement or suitable replacement of the 3. So this way I can find the current using Ohm's law, that I equals to V by R equivalent, that is 10 by, there is 10 volt, R equivalent I have to find. If I get this value, then I can get I. Now let us find R equivalent. So the R equivalent of the circuit is these two are in series, and that is in parallel with 4. So 5 and 4 are in parallel. So 5 ohm parallel 4 ohm. This is 9. This is 20 by 9 ohm. Now the current, main current that is drawn from battery is 10 divided by R equivalent, that is 10 divided by R equivalent comes out to be 20 by 9. 20 divided by 9. So that comes out to be, this is 2 here, this is 4.5 amps. So 4.5 amps comes out of this. So this comes out to be 4.5 amps. Upon reaching here, it is divided into 2 parts. You know what fraction of this total 4.5 will be diverted to this and other to this branch? We are interested in this. Now we know that the division of current, that will also discuss after this, that how to divide current, the current divider method. So the current divider method is what is current divider? Suppose we have got resistance here R1, resistance is R2, current coming is I1 goes through R1 and I2 goes through R2. Here it is again I. So obviously I is I1 plus I2. Now how to divide current? If I want current in this branch, current I1 in this branch is, you have to look at the resistance of the opposite branch. Resistance of opposite branch divided by total resistance into the total current. If it is a, so therefore I1, I want I1, then you can see here the resistance of the opposite branch divided by total resistance into I. So that will be R2 divided by R1 plus R2 into the total current. Okay. So this formula, and similarly R2 will be R1 divided by R1 plus R2 into I. So these are the formula you have to remember. Now coming back to the question was now this branch we had 2 plus 3 5 ohm here, and the other one having a resistance of 4 ohm. The current coming is 4.5 ampere. This is I. This I call I1 and this I call I2. I am interested in this because 2 and 3 are the two resistors present in this, so I made it to 5. Because whether writing 2 or 3 or write 5 or 1 or 4, the current will not change. The current is I1. So whatever current I1 will pass through 2 and 3 also pass through 5. So the current is not changing. So basically to find the current, I have to reduce this into a single resistance. So this 2 and 3 is reduced to 5. Now using this above formula, I1, I am interested in this branch. The current in I1 must be the resistance of opposite branch, that is 4, divided by total resistance, that is 4 plus 5, into the total current, that is 9 by 2. 4.5 is 9 by 2. So this 4 plus 5 is 9, 9 and cancels, this also cancels, is 2. It's 2 amperes. So if this 2 ampere goes in this branch, then the remaining is 2.5 should pass through here. So what I'm getting here is this comes out to be 2 ampere, and this should be 2.5, though I'm not interested in this because my question is only to find the power in this branch. So but still you can check it out. I want to find I2. If you want to find I2, uh, the current is this, the resistance of this total resistance is 9, so 5 by 9 into 9 by 2, 5 by 9 into 9 by 2 comes cancel is 2.5. That is the answer. But then when you get the current, then coming back to this, once you get the current in this branch, which is coming out to be 2 ampere, this comes out to be 2 amp. So this I1 is 2, so the answer is 3 into 2 square, that's 4 3 are 12. Right. This is the answer to this question. Okay, so this way you can find the, I can also find the resistor power consumed in the circuit. I can reduce the whole thing into total equivalent resistance, which I already calculated. So in that case you will get the power consumed by the whole circuit. You can find the power consumed by the whole circuit, or you can find the power consumed by individual resistors. Okay, thank you.